This is the cockpit of the Bloodhound supersonic car, my 1,000 mile per hour office. It's a carbon fibre monocoque. It is a single piece with all the structural strength built into it. And carbon fibre is an extraordinary material. It is the same high technology material from which we make modern jet fighters, Formula One cars, and in this particular case, the strongest safety cell in the history of motorsport. It is 7 layers of carbon fibre with then an aluminium honeycomb spacing and another 5 layers on the inside. This has produced a monocoque which is a total of 200 kilograms and took over 10,000 hours work to produce. It is a fantastic piece of technology and it needs to be phenomenally strong. To take the loads and the thrust from 210 kilonewtons, 130,000 horsepower of engine thrust at the back of the car, and to take the aerodynamic loads of up to 12 tons per square metre, and the suspension loads from the front suspension bolted on here. Boeing AMRC made this for us, and itself is an extraordinary piece of technology. 4 pieces of aluminium, each over 200 kilograms, were forged multiple times, literally heated and squashed to actually shape the grain to increase the strength of the aluminium. It's exactly the same process we used to manufacture the wheels, which you can see in the BHTV clip. Then they were machined down, so 800 kilograms of aluminium has now become just over 40 kilograms of aluminium. The rest goes for recycling, and we now finish up with the structural heart of the suspension. Onto the sides here, we're going to have double wishbones bolting, plus the dampers and the spring suspension. On the end of that, 2 90 centimetre diameter, 100 kilogram wheels will be spinning at over 10,000 RPM. The total suspension loads designed to take over 30 tons at the front end. So these are the sorts of forces that would tear apart any normal race car, any normal road car. This is an extraordinary piece of extreme technology. All of that load has to be passed through this aluminium into the carbon fibre monocoque, which is the structural heart of the car. The canopy has to do several things. First of all, the windscreen has to keep the wind off my face. At 1,000 miles an hour, it gets very windy. There's a hole here physically to allow me in, but most importantly, it is a key aerodynamic part of the car. Because out here, the airflow is doing over 1,000 miles an hour in this direction. Back here, we've got a jet engine which needs to have the airflow going less than 750 miles an hour, below the speed of sound. Otherwise, it breaks down as it hits the blades. So we actually have to slow the airflow down through about 300 miles an hour or more in this distance. So the shock waves coming off the canopy, off the top of the canopy and across the start of the intake are a key part of the airflow system for the jet engine. To give you an idea of the volume, if you opened your front door and saw this picture, with the jet engine running at full speed, it would suck all of the air out of your house in about 3 seconds. The whole house, it would empty 200 cubic meters, would go down there in 3 seconds. The flow rate is just phenomenal. So the airflow management here and the speed management is an incredible challenge. Of course, the other key part is being able to see where I'm going. This is where the canopy will go. We've got the mock-up here because the real one is away, having the acrylic windscreen fitted to it right now. They literally take a block of hot acrylic, and the PPA group are actually stretching this and wrapping it around a mould, which will produce about a 12mm piece of plastic. And they'll do that twice. They'll then glue these 2 pieces together to make them even stronger. So I've now got a 25mm thick piece of plastic. And I'm looking through it at a very shallow angle through here. So I'm actually looking through about 50+ millimeters of plastic, curved plastic, which needs to be optically perfect so I can see what I'm doing. That curved plastic is that thick and that strong to survive the 1,000 mile an hour airflow, and also, worst case, to take a bird strike from a big bird, maybe 2 kilograms at 650 miles an hour, or half that weight at approaching 1,000 miles an hour. All of this technology will give me the most extraordinary working environment with which to get Bloodhound up to 1,000 miles an hour, and also the highest level of protection we can possibly get. It's a brilliant piece of engineering.